हेलो एवरीवन। सो आज हम अपना न्यू टॉपिक स्टार्ट करते हैं विच इज जियोमेट्रिकल प्रोग्रेशन। सो फर्स्ट ऑफ ऑल जियोमेट्रिक प्रोग्रेशन क्या होता है। हमने प्रीवियस लेक्चर में देखा था अर्थमेटिक प्रोग्रेशन में। अर्थमेटिक प्रोग्रेशन में क्या हो रहा था, हमारे पास जब भी हम नेक्स्ट टर्म निकाल रहे थे तो नेक्स्ट टर्म के लिए हमें प्रीवियस टर्म में कांस्टेंट नंबर ऐड करना पड़ रहा था। सो जियोमेट्रिक प्रोग्रेशन में क्या होता है, हमें एक कांस्टेंट नंबर आर मल्टीप्लाई करना पड़ेगा नेक्स्ट टर्म निकालने के लिए। ये हमारे पास प्रीवियस टर्म है कुछ, इसमें ये मल्टीप्लाई किया तो हमें क्या मिलेगा, नेक्स्ट टर्म। So what is the definition of geometric progression? So a sequence in which each successive term is obtained by multiplying a constant number in the preceding sum term। सो क्लियरली हम देख सकते हैं, हमने जब एपी की डेफिनेशन लिखी थी तो एपी में हम यहाँ पे कांस्टेंट नंबर ऐड कर रहे थे एंड जीपी में मल्टीप्लाई कर रहे हैं। एंड द इम्पोर्टेंट थिंग इज first term of an GP should not be 0। और जो हम एक फिक्स नंबर मल्टीप्लाई कर रहे हैं उसे हम नेमली दे देते हैं R। R is common ratio। Okay, so if we have a sequence A1 A2 and so on AN, then what will be the first term? It will be A. What will be the second term? Multiplying A by R, it will be AR. What will be the third term? It will be AR square and so on. If I'm writing nth term, then what it will be? AR raised to the power n minus 1. Okay, so writing here is some example of GP. First, what it will be? I'm writing 3, 6, 12, 24, 48. Is it GP or not? So clearly we can check. 3 cross 2 6, 6 cross 2 12, 12 cross 2 24, 24 into 2 is 48. So the common ratio is same. So this is an GP. Now if I'm writing here 2, 6, 18, 36, 54. 2 into 3 6, 6 into 3 18, 18 into 2 36, and it will be 3 by 2. So clearly we can see the common ratio is not same, so not GP. So now I'm writing here. We know the formula of nth term of n GP. It will be a AR raised to the power n minus 1, where A is first term, R is common ratio, and AR is nth term of n GP. So if I want to find the sum of n terms in a GP, then what it will be? It will be, if I'm writing Sn is equals to A1 plus A2 plus A3 and so on An, where A1, A2, A3, An is in GP. So I'm writing here the value A1 is AR, AR square plus AR raised to the power n minus 1. So clearly if I'm taking the common a, then what it will be? A1 plus r square plus r raised to the power n minus 1. It is a, and what it will be? R raised to the power n minus 1. Sorry. So what it will be? A r raised to the power n minus 1 upon r minus 1. How it comes from? Because we know that r raised to the power n minus 1, which is equals to r minus 1 into 1 plus r square and so on, r raised to the power n minus 1. So if I want the value of this function, then this r minus 1 goes to the denominator of this side. Okay, so this is the formula of sum of n term of an GP. Now I'm writing here some questions here, that the nth term of an sequence 3 root 3 1 is 1 upon 243. Then find n. So what we have given, that we have given a sequence and we have given the nth term is 1 upon 243. Then we have to find what is n. So first of all, we have to check whether this is an AP or GP, because we know the formula of only progression. So we have to check whether this is an AP or GP. So if I'm checking here, then what it will be? 3 into 1 upon root 3, then it will be this. It will be this. So this sequence is a GP. Now I'm writing here the formula of nth term of an GP. AP. So clearly, what is AN? Here AN is given as 1 upon 243, A is 3, and uh, R is 1 upon root 3 raised to the power n minus 1. Now this is 1 upon 3 raised to the power 5, what's 3, and it will be 1 upon 3 n minus 1 by, okay. So 1 upon 3 n minus 1 by 2, it will become 1 upon 3 raised to the power 6. That implies 1 upon 3 n minus 1 by 2, which is equals to 1 upon 3 raised to the power 6. By comparing these equations, we get, what will we get? 6. N minus 1 is 12. So n is 30. So for the given sequence, the 243, 1 upon 243 term is 13th term. Okay. So now I'm writing here another example. In a GP, the second term is 82 and fifth term A2 plus A5, it will be 216, and the ratio of fourth term and sixth term, it is 1 by, sorry, it is 1 ratio 4, and all terms are an are integers. Then what we have to find? Then find its first term. Then find its first term. So by the given data in the question, first of all, what is A2? A2 is AR, A5 is AR4, A4 is AR cube, and A6 is AR5. So if I'm using A2 AR plus AR4, it is 216. Now A4 upon A6, it is AR cube upon AR5, which is 1 by 4. So by this equation, what we are getting here, 1 upon R square, cancelling A to A, and it will be 1 upon R square, 1 is equals to 1 by 4. So R is equals to plus minus 2. Now, if I'm putting if R is equals to 2, then 2A plus 16A, which is equals to 216, 18A, which is equals to 216. So A is 12. And if R is equals to minus 2, then what it will be? What will be the equation? What will be the equation? So the equation will be minus 2A plus 16A, which is equals to 216. So 14A is equals to 216. So A is equals to 216 by 14, which is equals to 108 by 7, not an integer. So A बराबर 12 and R is equals to 2. This is the required data for this question. Now, if I'm writing here and another question, evaluate 5 plus 55 plus 555 plus 5555 plus up to n terms. So first of all, this is not in AP, this is not in GP. So we have to make it in the GP. So how we will make it? Firstly, if I'm taking common 5, then what it will be? 1 plus 11 plus 111 plus 1111 plus and so on. If I'm multiplying and dividing 9 by this term, then what it will be? 9 plus 99 plus 999 plus 9999 plus and so on. If I'm writing here, 9 is 10 minus 1. What is 99? 10 square minus 1. What will 999? 10 cube minus 1. 10 raised to the power 4 minus 1. N terms. Up to n terms. So now if I'm writing 5 by 9, 10 plus 10 square plus 10 cube plus 10 4, 10 raised to the power n minus n, because minus 1 minus 1 minus 1 minus 1 n at time, then it will be minus n. So clearly we can see this is an AP. So how we can solve this? First term is 10 and r is 10, so 10 raised to the power n plus 1. Here is n term, sorry, here is only uh, n minus 1 term. So we are writing here only n minus 1 upon r minus 1 minus n. What it will be? 5 by 9, 10 raised to the power n plus 1 minus 10 minus 9 n upon 9. So it will be 5 by 81, 10 raised to the power n plus 1 minus 9n minus. Okay, have we got it? So now we are writing as some properties of an GP. Properties of GP. So what are the properties of GP? So first one is, so what is first property of GP? If ABC are in GP, then B square is equals to AC. If ABC are in a GP, then B square is equals to AC. In general, what we can write here, if A1, A2, A3 dot dot dot, AN minus 2, AN minus 1, AN are in GP, then so have you remember we can write these types of formula for an AP. Then what we will write here, the sum of the equidistant terms of an GP from beginning and end will be constant, and it is equals to the sum of the first and last term. So in this GP we are not talking about the addition, so it convert to the multiplication. So what it will be, A1 AN, which is equals to A2 AN minus 1, which is equals to A3 AN minus 2, and so on. Okay, so have you understood this? So now I'm writing here another property. In each term of an GP, be multiplied or divided or raised to power by a same non-zero number, then the resulting sequence is also an GP. So what does it mean? If we have an GP A1, A2, A3 and so on are in GP, then if we are multiplying each term with a fixed number, then KA1, KA2, KA3, KAN also in GP. If we are dividing each term by a fixed number, A2 by K, A3 by K, AN by K also in GP. And if we are raising to power by the number, same number, a1 k, a2 k, a3 k, and so on, an raised to the power k, are also in GP. So clearly, can you compare this with the AP? Like in the AP, it is true for addition, subtraction, multiplication, and division, and in the GP it will true for multiplication, division, and raised to the power by a same constant number. So now, I'm writing here an another property of an GP. What is the another property? If A1, A2, A3, and so on, and B1, B2, B3, and so on are 2GP with a common ratio R1 and R2 respectively. Then the sequence A1, B1, A2, B2, we are multiplying the corresponding element of these GP. So A3, B3, dot dot dot, AN, BN, dot dot dot, is also a GP with a, and what is the interesting fact, with a common difference. What will be the common difference? Can anyone guess? It will be R1, R2. Okay. So now I'm writing here and another very important property. Please start this the property, like if A1, A2, A3 are in GP, where each AI greater than 0, then ln A1, ln A2, ln A3 are in, can anyone guess this? If these are in GP, then ln A1, ln A2, ln A3 are in AP, and converse is also true. What is the meaning of the converse is also true? Meaning if ln A1, ln A2, ln A3 are in AP, then A1, A2, A3 are in GP. Okay, this is an important property. Remember, this is an important property. So now we are writing here and another property. So if we have to assume three consecutive terms in a GP, then what will we assume? What will we assume? Any three consecutive term of an GP can be taken as A by R, A and AR. And for four terms, we have taken such kind of term. If we are multiplying these term, then it will be A cube. Four terms, it will be A upon R cube, A upon R, AR, AR cube. So for this, common ratio is, what will be the common ratio of this GP? It will be R square. Remember this, the common ratio is not R for this GP, it will be R square. And CR for this GP, it will be only R. We can clearly see that. Okay. So now I'm solving here an example which is related to this property. Like I'm solving a question. Find the three terms in GP having sum 26 and product 216. So let us assume we are talking here about the product. So what will we choose? The three terms of an GP are A by R, A and AR. Then A by R, A, AR is, sorry, AR is 216. That is A cube is 216. So A is clearly 6. Now what is the sum of these three terms? AR is 216. So if I'm writing here the value of A is 6, 6 plus 6R plus 6R square, it will be 216R. Okay. So oh sorry, the sum of these terms is 26. So it will be 26R, 26R. So what it will be? 6R square minus 20R plus 6, which is equals to 0. So for solving this equation, what will we get? We get R is equals to 3 and R is equals to 1 by 3. If I'm taking R is equals to 3, then what will be the A by R? A and AR. If A is 6 and R is equals to 3, then this is 2, 6 and 18. If A is 6 and R is equals to 1 by 3, then what it will be? 18, 6. These are two GP for the. Now I'm writing here another question. Find the product of first 11 terms of a GP whose sixth term is 5. So clearly we have given that we have an GP A1, A2 and so on A11. And what we want to solve, we have to solve product of I बराबर 1 to 11 AI. That is A1, A2, A3, A4 and so on A11. Product of these 11 terms. So clearly we know that if A1, A2 and so on A11 are in GP, then A1, A11 which is equals to A2, A10 which is equals to A3, A9 which is equals to A4, A8 which is equals to A5, A7 which is equals to A6 whole square. As we have given that the sixth term is 5. So A1, A11 is 25 and each term will be 25, 25, 25, 25, and this is 5. So I बराबर 1 to 11. AI is 25 raised to the power how many pairs? 1, 2, 3, 4, 5. 5 dot A6. This is the required answer. So now this is the basic theory of the